All right, I'm gonna do a quick video for you guys on the counting principle um, and also permutations. I've uploaded some Khan Academy videos so far, but I want to do my own thing and show you some things you can do on the calculator as well. So these right here are just some notes that I took earlier, and I'm just going to go over them with you. Maybe I can upload these notes onto Google Classroom. But here's an example of the counting principle. If I roll a fair die and flip a fair coin, how many different outcomes are possible? Right? So this first branch represents your coin flip. You either get heads or tails. And then you also roll the die. So if you get heads, then on the coin flip you can get a 1 through 6. Or if you flip tails, you could still get a 1 through 6. So you can see there are 12 different possible outcomes, right? You can get heads in 1 or tails in 1, heads in 2 or tails in 2, all the way through heads in 6 and tails in 6. So that's a tree diagram. That's one way to figure it out. Another way is just to make a table. Over here you have the coin flip heads, tails, and right here you have the outcome of the die, 1 through 6. And then, you can get heads 1, heads 2, heads 3, heads 4, heads 5, tails 1, tails 2, tails 3, and so on. All right, so it's a very simple idea. If you just want to know how many outcomes there are, as long as these are two independent events, which they are, the coin flip doesn't affect the roll of the die and vice versa. Then you just multiply the possibilities for each event. So there's 2 outcomes possible on the coin flip. There's 6 outcomes possible on the die. So 2 times 6 is 12 different outcomes. And then from there, we would, need to get into a little probability. So if I were to ask, what is the probability of rolling a 6 and getting heads? Then, as you can see, this is how you'd write that symbolically. So 6 on the die and heads on the coin. That's just since they're independent, that's just the probability of getting a 6 times the probability of getting heads. 1/6 times 1/2 is 1/12. Okay. And you can see there's the outcome right there, heads and 6. So that's 1 out of 12 equally likely outcomes. And this, of course, only works because all of these 12 outcomes all have the same probability of happening, right? Each one has a probability of 1/12. All right, so here's some other examples. Let's say you want to flip a coin 4 times. How many outcomes are possible if you flip a coin 4 times? So I just write 4 blanks because I'm doing 4 things. There's 2 things that can happen for each flip. So it's 2 times 2 times 2 times 2, which is 16 outcomes, right? 2 times 2 is 4 times 2 is 8 times 2 is 16. Another way to write that would just be 2 to the 4th power. 2 to the 4th power is 16. All right, here's another example. Let's say you have a combination of some sort, like say a lock, and there's 3 numbers that you have to turn your dial to unlock the lock, right? So you've got to choose 3 numbers, and there's 50 possible numbers. Let's say 1 through 50 are the possibilities on the lock. How many different combinations are possible? Well, we're assuming that you can use the same number more than once. So there's 50 possible numbers on for the first one, 50 again for the second, 50 again for the third. So that's 125,000 different combinations. But if there were no repeats, so for instance, let's say combination like 10, 10, 10 was not possible, right? Let's say you could not repeat a digit at all, only unique numbers. So then there's 50 possibilities for the first number, but after you use that number, then there's only 49. And then after you use that number, now there's only 48. So that would be 50 times 49 times 48, which is 117,600 combinations. All right. All right. So what we have here is this is the idea of a permutation, at least a mathematical permutation. And if you watch the other videos, you know that there's a formula for permutations, right? So it's like for permutation formula, it's we use the symbol n. So n represents the total number of things possible. So like if I were going back up to this combination problem, n would be 50. P just stands for you want a permutation, meaning all the different ways you can arrange the 50 numbers. And R is the number that you're going to choose out of n, right? So for instance, well, let me write the formula. So that's going to be n factorial over n minus r factorial. And hopefully you watch the other videos and you know what a factorial is at this point, right? So an example of using this formula, let's say I wanted to use it here, right? So it has to be a no repeats kind of problem, no repeats. So it only works if there are no repeats allowed, like number 4. This formula does not work for number 3 because repeats are allowed. Right, so if I wanted to figure out number 4 using the formula, instead of n it would be 50 because there's 50 numbers possible. P and then R would be 3 because you only want 3 of those numbers out of 50, right? So you're choosing 3 out of 50. Okay, so n factorial would be 50 factorial over n minus r factorial. So that would be 50 minus 3 factorial, like that. All right, so let's simplify that a little bit. That's 50 factorial out of what? 50 minus 3 is 47 factorial, right? All right, so what does that mean? Let's see. Well, 50 factorial is 50 times 49 times 48 times 47 all the way back to 1, right? It just keeps going. And then over 47 factorial, which is what? 47 times 46 times 45, all the way back to 1. As you can see, this top part starts at 47 and goes all the way back to 1, right? 47 all the way back to 1. It's going to cancel with this down here because those are the same thing. So I can rewrite it really as 50 times 49 times 48 times 47 factorial, right? In other words, this part right here, 47 times 46, that from there down to 1 is 47 factorial over all that, which is really 47 factorial. Those two cancel each other out, leaving you with what we did above, which is 117,600. Okay, so as you can see, the formula is hardly worth using in a situation like this. It was so natural up here just to do the problem like, okay, well, there's 50 numbers available for the first number, and then there's 49, and there's 48, and we're done. But you do need to know the formula. And I'm going to show you how to use your calculator. Now, I know you don't have your TIs, but you do have access to Zoom. I'm not Zoom, sorry. Desmos, right? So here's Desmos on my phone. You can download Desmos on your phone, all right? So let's see here. To get to a permutation like this, you go to Functions and then Stats. And if you notice down here, you have NCR and NPR. We're doing NPR right here. And then you just put in the two numbers in the order. The big number goes first, so it's 50, and then comma 3. And there it is, 117,600. All right, so you can use Desmos since you no longer have a, most of you anyway, don't have a TI-84 calculator anymore. But this Desmos will do everything that we need. All right, so there's a quick lesson on permutations. Let me do one more problem. So let's say you have the word how many ways can you arrange the letters in the word math? All right, so that's a permutation problem. And we could write them all out. It would take me a little bit, but let me just give you an idea of what I'm talking about. So you have this arrangement. That's one arrangement. I could switch the T and the H there and get M-A-H-T. That's another arrangement. I could put, let's say, the T after the M, and then the A and the H. I could put the M and the T, and then the H and the A. I could put, what, the H after the M, and then the T and the A. I could put M, H, A, and the T. And that's just the number of ways to do with the M in the front, right? I don't have to put M in the front. I could put A in the front. So I could have A, M, T, H. I could have A, M, H, T. I could have A, T, M, H. I could have A, T, H, M. I could have A, H, T, M, or A, H, M, T, and that's with A in the front, right? So basically there's 6 ways to do it with M in the front. There's going to be 6 ways to do it with A in the front. There's going to be 6 ways to do it with T in the front. There's going to be 6 ways to do it with H in the front. But a quicker way is just to say, okay, there's 4 letters, and they're all unique. So there's 4 letters that can go here. And then when you're done, once you put a letter there, then now you only have 3 left to go here. And then you have 2 left, and then you have 1 left. So it's the multiplication principle, or the counting principle again. That's the same as 4 factorial, right? That's the same as 4p4. These all do the same thing. They all give you the same answer. Try it on your calculator and you'll see. So there's 24 ways. 24 ways to arrange these letters. And I guess I'll stop there. That's probably enough. Thanks for watching.